When people talk about AI chips, the first name that usually comes up is NVIDIA. But if we only talk about NVIDIA, we miss another important company in the story, AMD. AMD is often described as a gaming graphics card company. That is partly true, but far too narrow. AMD competes in two of the most important markets in computing, CPUs and GPUs. In GPUs, AMD competes with NVIDIA. In CPUs, AMD's longtime rival is Intel. To understand AMD, we have to look beyond the current AI boom. This is not just a story about one hot stock or one new AI chip. It is the story of a company that nearly disappeared, survived multiple crises, and found its way back into the center of the semiconductor industry. AMD's story begins near the roots of Silicon Valley. In 1947, scientists at Bell Labs built the first transistor, one of the most important inventions of the 20th century. One of those scientists was William Shockley. As a researcher, Shockley was brilliant. As a manager, he was deeply flawed. A group of talented engineers eventually left Shockley's company and founded Fairchild Semiconductor. Fairchild became one of the great talent factories of Silicon Valley. Intel came from Fairchild. AMD also came from Fairchild. In that sense, AMD and Intel were connected from the very beginning. Intel was founded by Robert Noyce and Gordon Moore, two of the most important figures in semiconductor history. AMD was founded 1 year later by Jerry Sanders, who had also worked at Fairchild. But the two companies did not start from the same position. Intel had elite technical talent, strong investor confidence, and early momentum. AMD was much smaller and less powerful. In the beginning, AMD was not trying to dominate the market, it was trying to survive. One reason AMD survived was the second source model. In the early semiconductor industry, large customers often did not want to depend on a single supplier. If a chip was important, they wanted another company that could also produce it. That reduced supply risk and gave customers more control. AMD often served as a second supplier for Intel-compatible chips. This kept AMD close to Intel. It also kept AMD in Intel's shadow. But when the personal computer boom arrived, that shadow became valuable. IBM entered the PC market. Intel's x86 architecture became the industry standard. As x86 spread through the PC industry, AMD benefited as a compatible supplier. This gave AMD growth, but it also created a strategic problem. Following Intel could keep AMD alive, but it could not make AMD truly independent. If AMD wanted to become more than a lower-cost alternative, it needed its own technology and its own product leadership. In the 1990s, AMD increased its research and development spending. It also acquired NextGen, a chip design company with important x86 talent. That acquisition helped AMD develop its K-series processors. Then came one of AMD's great early breakthroughs. In 1999, AMD released the Athlon processor, based on the K7 architecture. Soon after, AMD beat Intel to the first x86 processor to pass 1 GHz. For AMD, this was not just a technical milestone, it was proof that the company could challenge Intel directly. For years, Intel had been treated as the natural leader in PC processors. Athlon changed the conversation. AMD could now compete on performance, not just price. In the early 2000s, AMD continued with the K8 architecture and helped bring 64-bit x86 computing into the mainstream. In some areas, AMD was no longer catching up. It was leading. For a period of time, AMD came very close to Intel in parts of the CPU market. That success created ambition. AMD began thinking about its next major move. The company understood that the future of computing would not depend only on CPUs. Graphics processors were becoming increasingly important, and the GPU market had consolidated around NVIDIA and ATI. If AMD could combine CPU and GPU capabilities, it might build a more powerful computing platform. That logic led AMD to ATI. ATI was one of the major graphics chip companies. AMD saw an opportunity to own both central processing and graphics processing. The idea was strategically attractive: combine CPU and GPU technology, serve more customers, and compete across a broader part of the computing stack. Looking back from the AI era, the strategic logic was right. If AMD had never bought ATI, it would probably not have a serious seat at the AI accelerator table today. Its GPU technology, graphics teams, and accelerator roadmap all trace back in part to that decision. But a good strategic direction can still create enormous damage if the timing and price are wrong. AMD bought ATI in 2006 for roughly $5.4 billion in cash and stock. For AMD at that time, this was a very large deal. It used cash, added debt, and increased financial pressure. Suddenly, AMD was fighting on two fronts. In CPUs, it had to fight Intel. In GPUs, it had to fight NVIDIA. That would have been difficult for any company. For AMD, it became nearly overwhelming. Just as AMD was digesting ATI, Intel struck back with its core architecture. Intel's new processors delivered strong performance and strong power efficiency. The competitive gap widened again. AMD's financial position weakened. It had debt from the ATI acquisition. It had to fund CPU development, GPU development, and manufacturing. Its market share declined. Its products struggled to maintain momentum. The ATI acquisition later became valuable, but at the time it nearly broke the company. The timing was especially painful. AMD had bought its way into graphics just as Intel was regaining strength in CPUs. At the same time, NVIDIA was becoming more dominant in discrete GPUs. AMD was no longer fighting one giant, it was fighting two. And unlike Intel, AMD did not have a massive profit machine to fund every battle. That is one reason the next decade was so difficult. The company had the right long-term idea, but not enough financial strength to absorb the short-term pressure smoothly. In 2008, AMD made another major decision. It spun off its manufacturing operations, creating what later became Global Foundries. At the time, this looked like a forced survival move. AMD needed cash and flexibility. Owning advanced semiconductor manufacturing was expensive, and AMD could no longer carry the full burden. But in hindsight, this decision became one of the most important turning points in AMD's history. By separating chip design from chip manufacturing, AMD became lighter. It could focus more on architecture, design, and product execution. It could rely on external foundries instead of trying to own the entire manufacturing chain. This was especially important later, when AMD could work with TSMC and benefit from advanced process technology without owning fabs itself. Intel, by contrast, remained deeply tied to its own manufacturing operations. That gave Intel advantages for many years, but later also created problems when its process technology fell behind. AMD's foundry split did not solve everything immediately. During the early 2010s, AMD was in serious trouble. Its desktop CPU share had fallen. Its server CPU share had collapsed. Its balance sheet was strained. The company sold assets, cut costs, and tried to stay alive. Many analysts believed AMD might slowly fade out of the high-performance chip market. This was not a normal downturn. AMD's survival was in question. That context matters because turnarounds in semiconductors are unusually hard. In many industries, a struggling company can cut costs, simplify the product line, and recover within a few quarters. In chips, the product cycle is much longer. A new architecture can take years. If a company falls behind technically, it cannot fix the problem with a marketing campaign or a price discount. It has to rebuild the engineering foundation. That was the challenge Lisa Su inherited. Then in 2014, Lisa Su became CEO. Lisa Su was not a financial executive brought in to manage decline. She was an engineer. She earned a PhD in electrical engineering from MIT and had deep semiconductor experience from companies including IBM. When she took over AMD, the company was near a breaking point. It needed cost discipline, but cost-cutting alone would not save it. AMD needed a technical and strategic reset. Lisa Su's most important decision was to refocus AMD on high-performance computing. For years, AMD had often competed on price. That helped it sell chips, but it also trapped the company in lower-margin segments. Being the cheaper option can keep revenue alive, but it does not build a strong long-term position if the company lacks performance leadership. Lisa Su understood that AMD could not rebuild itself by being the cheaper alternative forever. It had to make high-performance products again. That decision led to Zen. Zen was not just another CPU update, it was a reset of AMD's technology roadmap. The company needed an architecture that could bring it back into serious competition with Intel. In 2017, AMD launched Ryzen processors based on Zen. The results changed AMD's image. Ryzen delivered strong performance, competitive pricing, and a new sense that AMD was no longer simply surviving. It was competing again. Zen also used a more modular approach that helped AMD improve flexibility and manufacturing efficiency. Later generations would build on this foundation and push AMD further into both consumer and enterprise markets. Ryzen brought AMD back into serious competition in consumer CPUs. But the bigger prize was not the desktop PC. The bigger prize was the data center.